we are back again. I have a spanking new set of clothes, courtesy of the teaching company, all the way down to new socks, so I am just brimming with manly self-confidence, and thus am willing to tackle the issue of stress and female reproduction. Now, of course, you know the drill by now, which is going to be short-term, running away from the lion, 30 seconds, got better things to do than thicken your uterine walls, long-term problem, chronic stress, and you begin to impair the reproductive system. Now, starting off, a great way to appreciate just how much this is one of those indulgences, reproduction, one of those ones that fall under the auspices of big, expensive, long-term, optimistic, and this is no time for it, is to appreciate just how expensive some aspects of female reproduction is. Best estimates are 50,000 calories that you go through over the course of a pregnancy, about 1,000 calories a day nursing, and this is simply something that's very tough to afford when you're running for your life. And in the face of chronic stress, this is the sort of realm that gets greatly impaired. And of course, you know where we go next with this, which is chronic stress in the form of psychological, psychosocial. It makes no sense at all for your body to say, oh my God, this is too expensive, let's defer until another period. Once again, you have that same logic that has haunted us in terms of stress-related disease. Real physical stressors, the stress response is wonderfully adaptive. Psychosocial stressors that we humans specialize in, and it makes no sense to turn on the chronic stress response, and this is one of the realms where you pay a price. Now, to appreciate it, we've got to tackle one of those endocrine axes, as talked about in the second lecture, have to tackle one of those pathways, which, as you'll recall, starts with the master gland, your brain, releasing a hormone that has an effect at the pituitary, which then, in this case, has an effect on the ovaries. Now, it's actually two different sets of hormones that wind up being relevant here. The first one, for the first half of one's reproductive cycle, known as the follicular stage. What you're doing there is you're maturing follicles. You're maturing eggs that will be released around day 14 of the cycle, and then you transition to what's called the luteal phase. Notion being, if conception occurred right around that 14th day, plus or minus a couple of days, what you now need to do is prepare your body, your uterus, for starting a pregnancy, implanting this fertilized egg. So what are the hormones involved? Follicular stage, that same axis again as promised, brain, pituitary, peripheral glands. You have, starting off, a hormone that lots of people are familiar with, coming out of the pituitary, luteinizing hormone. Luteinizing hormone, once again, do not write these down, do not panic if you don't know these terms and don't want to learn these terms. You got a hormone that comes out of the pituitary, which is going to stimulate egg maturation. And of course, what you know is the pituitary hasn't a clue when to release luteinizing hormone under the control of the brain, the hypothalamus, which releases the bizarrely named luteinizing hormone releasing hormone. So out comes this LHRH from the hypothalamus, has an effect on the pituitary, out comes LH, and you are now causing preparation for fertilization. You also are releasing follicle-stimulating hormone out of your pituitary, and collectively what LH and FSH are doing is maturing eggs, and producing estrogen coming out of the ovaries plays a critical role in that. Now, once you transition over to the luteal phase, a different hormone dominates, and that's known as progesterone. And all you need to do to get a sense of what it's up to is progesterone progestational. What it does is prepare the uterus, thickening it, preparing it for implantation of the fertilized egg. Okay, so we've got all the basics of the system under our belt here, and what we now transition to, of course, is what's occurring during stress. What's occurring with this hypothalamic pituitary gonadal axis. Now, what you see is a very complicated version of exactly what we know by now. First thing that happens, remember that hypothalamic hormone, luteinizing hormone, releasing hormone, the first thing that happens during stress is it releases less of the stuff. And that's occurring within seconds. Which hormones are responsible for that? You remember some of the dread names from earlier on. Glucocorticoids. Glucocorticoids work up in the hypothalamus to inhibit the release of LHRH. Another hormone is relevant there, one that was mentioned for 1.5 seconds in that prior lecture, which now begins to be relevant for the first time, that hormone beta-endorphin. Beta-endorphin, about the only thing that sort of registers with most people about beta-endorphin is it's got something to do with blocking pain or runner's high, endorphin high. What's it doing? Instead, working at the hypothalamus to block LHRH release. Very few hormones do only one thing, so this is another function of beta-endorphin. Don't panic. Do not write these down. Again, get the general theme. So we've got the first thing that happens, which is decreased hypothalamic, decreased brain release of this LHRH. And by all logic, what that should now do is have a consequence at the pituitary. For lack of that LHRH stimulation, the pituitary is now going to be releasing less LH and FSH. But, oh, that's not enough. Your brain does not trust that things can be solved merely by shutting off LHRH secretion. Another thing that happens is you send signals, hormonal stress signals, you send signals to the pituitary to make it less responsive to whatever LHRH is coming out. And you could probably guess the mechanism by now. Just like every other hormone, RH works by way of its receptor in the pituitary. The pituitary starts making less of these receptors. So you've got a double whammy there. Less of the signaling hormone is coming out of the brain, and the pituitary is less sensitive to that. So we know the consequence there already. There's going to be less LH, less FSH coming out, and thus the ovaries are going to be less stimulated to release estrogen. And once again, the same theme, just in case the pituitary is screwing up and still releasing some of that LH and FSH, the stress response, heavily glucocorticoids, are working down at the ovaries to make them less sensitive to LH and FSH. And you guessed that there are LH receptors in the ovaries and FSH receptors, and there's fewer receptors. So you've got less of the hypothalamic hormone, and the pituitary pays less attention to it. You've got less of the pituitary hormones coming out, and the ovaries pay less attention. And the result is lower estrogen levels and less likelihood of fertilizing an egg. Now, the next thing that kicks in is less progesterone. That's another step in the pathway. Those same stress hormones and the same ones begin to pop up over and over. Glucocorticoids, beta-endorphin, they're also blocking the release of progesterone. And what you've got at this point is not only were you not releasing LH, FSH, estrogen, and maturing the eggs, but just in case against all these ridiculous odds, you somehow managed to get an egg that matures sufficiently through this follicular stage that it actually gets fertilized. What you've now done is you are making sure the uterus is not matured enough for this fertilized egg to implant. And the way you do that is exactly what we were just talking about. You secrete less of that progestational progesterone. You don't thicken the uterine walls, and it's less likely that the rare fertilized egg is actually going to implant there. One additional hormone that's going to become very relevant soon has a role in that, a hormone called prolactin. And we're going to see all sorts of things that prolactin does. One of the things it does in this case is it counters the effect of any progesterone that you still manage to dribble out despite the stress signals. What prolactin also does is thin out your uterine walls. So what should impress you by now is this is an incredible number of mechanisms for shutting down this reproductive ovarian axis at the level of the brain, at the level of pituitary sensitivity, the brain signal, at the level of pituitary ovarian sensitivity, all these steps. There's one really interesting additional step that comes in there, and it's got to do, oddly enough, with fat cells in females. And it's got to do with a very, very unlikely thing that females do, including human females, which is they secrete a certain amount of male sex hormones into the bloodstream. androgenic hormones like testosterone. Where are those coming from? From the adrenal glands. Remember, what the adrenal glands are up to is making adrenaline, epinephrine, glucocorticoids. In females, bizarrely, they also make adrenal androgens. Not a ton of this stuff, maybe 5% the levels you would see in a male. Nonetheless, you got to get rid of this stuff. Unfortunately, as I noted there, fat cells come into play here, which is fat cells have this enzyme that could do like biochemistry 101. They could take the circulating testosterone and convert it to estrogen. That's great. Everybody lives happily ever after. You've turned these bizarre, unlikely circulating androgens into estrogen, and everything is working fine. But what if you're stressed? What if you're stressed like the locusts have come and eaten your crops and you've been subsisting on 1,000 calories a day? What if you were slowly beginning to starve? What happens? Your fat deposits begin to go down. You begin to get depleted of fat. You're starving. And what happens is after a while, you have too few active fat cells to do that testosterone to estrogen conversion. And at that point, you are up the creek for two reasons. First off, you're putting less estrogen into the bloodstream. That's not that much of a big deal. It's a tiny amount. But the biggest consequence is you're now not breaking down that testosterone. Its levels build up and mess up things at the brain, pituitary, all of that. So that's this weird, from out of left field mechanism that's also relevant, this oddity of females making a certain amount of male sex hormones, and when you don't have much fat cells going there for you because of starvation, you don't do that conversion. So that's a major reason why starvation can shut down ovulation. That's also a major reason why voluntary starvation can do the same. Anorexia nervosa, one of its characteristics is that you've shut down ovulation very early on. It's the fat depletion. That's also the reason why some women who do tons and tons of exercise will stop ovulating as well. Again, the fat deposit's going down. And this has actually been widely studied, the ratio of fat to muscle, the amount of fat stores, the readiness with which that conversion is going on. This has been studied in all sorts of cases. For example, in kids, prepubescent kids, most often studied in terms of girls who are very, very intense athletes, typically gymnasts, ballet dancers, the ones who are doing 6 hours a day. And what you will see is a very significant delay with the onset of puberty. And this was even shown a few years ago, a study of gymnasts from the Romanian Olympic gymnastics team. And those are those like 15-year-olds who weigh 60 pounds and are getting the gold medals. What was the average age at which these kids started menstruating? Approximately 19. Western average 12 and a half years. This is a huge effect in terms of delaying the onset of puberty. Once you've hit puberty, women who do tons of exercise, for example, runners, on the average, if you were running about 50 miles a week, that's typically when the fat deposits are getting below that threshold and you begin to have ovulatory problems. Now, I could be telling you the same exact story with males. Men who run that average of 45, 50 miles a week, typically there's a little bit of testicular atrophy, sperm count goes down. Okay, you were sitting there saying, wait a second, I thought exercise was good for you. Exercise is good for you. In fact, a lot of exercise is very good for you. That doesn't mean, though, that an insane amount of exercise is insanely good for you. At some point, you pass a point of optimal function. You pass a point of homeostatic balance, and too much of a good thing could be just as bad as too little. This winds up being very, very relevant. One of our themes again and again is optimal ranges, homeostatic balance. Okay, so what goes on at that point? What happens there is all sorts of problems with trying to make sense of this effect, trying to make sense of why the body is set up for responding to extreme athleticism. And what you've got is a theme we've had running through here. This is not typical. This is not typical for humans. Okay, how to get a sense of it. Sit down some hunter-gatherer from the Kalahari Desert and explain to them, you know, back where I come from, we have so much food and so much free time that sometimes we'll just go run 26 miles for the sheer pleasure of it. And they're going to say, are you out of your mind? This is stressful. I mean, throughout hominid history, if you're running 26 miles in a day, you are either very intent on eating somebody or somebody's intent on eating you. This is not normal hominid behavior. So again, we see the possibility of passing a point of homeostatic balance, a homeostatic ideal. Now, as I mentioned a few minutes ago, a very interesting hormone comes into play here, prolactin. Prolactin, secreted during stress, and it turns out prolactin works, among other ways, by decreasing pituitary sensitivity to LHRH. It helps block the release of progesterone, all sorts of things like that. And as promised, prolactin is not merely a hormone released during stress. It does all sorts of other things. One interesting circumstance is if you have nipple stimulation, there's this neural loop going up to the brain or the hypothalamus, and you know that whole pattern, and out comes prolactin. Nursing causes prolactin release. And given all the things I just told you, prolactin release should be working as a contraceptive. Nursing is a contraceptive. That's why that works so well. Oh, you are sitting there saying, what does he know? He doesn't even have ovaries. Everybody knows nursing doesn't work very well. Nursing works wonderfully at being a contraceptive. The World Health Organization estimates there are more pregnancies prevented each year by nursing than by all other contraceptives put together. All you need to do is nurse the correct way, which I'm going to show you now. Aren't you folks who went for the audio version regretting it now? Okay, so what is human nursing like? Well, it depends. If you look at women in westernized countries, you see the following pattern. Typical pattern, you give birth, you nurse your child every couple of hours for 20 minutes or so. Typically, it begins to get lesser amounts of time. In the West, in the United States, women on the average nurse for 6 months. So what are you doing if every few hours or so you're nursing for 20 minutes? You begin to nurse, up go prolactin levels. You stop nursing, down they go. 2 hours later, up go prolactin levels, down they go. You get this scalloping pattern of prolactin up and down. That's not what humans and other primates normally do with nursing and thus with their prolactin levels. And to get a sense of that, this was first really studied in a bunch of hunter-gatherers, the folks living in the Kalahari Desert, the Kung Bushmen living in the Kalahari Desert, and they have a very interesting reproductive pattern, which is they have tons of sex. They don't use contraceptives, and despite all of that, women get pregnant about once every 4 years. What is causing that pattern to emerge? Now, the answer was very easy back then when people looked at hunter-gatherers and said, well, what's hunter-gatherer lifestyle like? Short, nasty, and brutish. They're all malnourished. They're all depleted of sufficient fat to ovulate. When people actually go and study hunter-gatherers, it becomes clear agriculture was one of the all-time stupid moves inventing that. Hunter-gatherers live very comfortably. As termed, they were the original affluent society. Folks like these are working 3-4 hours a day to get their day's calories. They are not short, nasty, brutish, and starving and depleted of estrogen. So what's actually going on there? What's going on was discovered a number of years ago by 2 anthropologists, Melvin Connor and Carol Worthman, and what they did was they noticed the prolactin pattern, the nursing pattern in women hunter-gatherers. And what you see there is something very different from in the West. Here's what happens. You give birth and you nurse your child for 30 seconds. And 20 minutes later, you nurse your child for 30 seconds. And 20 minutes after that, and you do that around the clock for the next 3 years. You carry your child on a hip sling and nursing every 20 minutes or so. You nurse throughout the night so that the mother hardly even wakes up. The baby just sort of crawls over and does some nursing. Mom continues to sleep. Oh, of course, Connor and Worthman are there up at night with their, infrared goggles and stopwatches, but everybody else is undisturbed. And 3 years into into it or so, your child is still nursing every 20 minutes or so. They come running in from the Little League game to nurse for a little bit. And when you have a nursing pattern like that, the first time you nurse for those 30 seconds or so, up go prolactin levels, and they're going to stay up for the next 3 or 4 years. That's the typical human and non-human primate pattern of nursing. And you do it that way, and you get this huge square wave nonstop of prolactin, you're not going to ovulate. That's what explains that delayed pattern of fertility. Think about that a second. Okay, what's the life history like for one of these women? Here's what you do. You hit puberty maybe when you're about 14 or so, typically a little bit later than in the West. And a year later, you're pregnant. And from what we just saw, 4 years later, you begin to ovulate again. A couple of cycles, you get pregnant again. 4 years later, a couple of cycles. Eventually, you hit menopause. And you suddenly realize, my God, over the lifespan of these women, they're having maybe a dozen periods. And you look at women in the West, and you get 300 or 400, and what you realize is the pattern of nursing in the West produces far more, like tenfold at least, more periods sloughing off of cells from the uterus than is the typical human and primate pattern. And there's lots of reasons to believe that increases the likelihood of a number of diseases in women, one, for example, being endometriosis. Okay, so that's another realm of vulnerability. Pushing on, another domain where stress becomes relevant, at least with all sorts of theorizing, is the realm of high-tech reproduction, in vitro fertilization. And anyone who has ever gone through this or been near someone who goes through this is enormously stressful. Your entire lifestyle is dislocated. You are getting filled up with synthetic hormones that wreak havoc with mood, with metabolism. Sex becomes a timed chore. It's a very high failure rate. You spend a fortune on it, usually not reimbursed by insurance. It's enormously stressful. And thus, there's been an obvious conclusion to reach, which is stress makes IVF, in vitro fertilization, less likely to actually work. Seems perfectly obvious. At this point, the evidence for it is mixed. It's so-so. It's not one of the more vulnerable realms of female reproduction when it comes to stress. And what I can absolutely tell you is the worst consequence of recognizing that stress might have something to do with success rates with high-tech reproductive approaches. The worst thing you can do is to have your physician, have your family, have your friends sit you down and say, oh, did you know that stress can disrupt reproduction in IVF? So just don't get stressed as you go through all of this. This is like ridiculous and one of the worst realms of applying the knowledge coming out of this whole subject. One additional realm now in terms of stress and reproduction, which is you've gotten the fertilization to occur, you've got a pregnancy to start, and something that is classically vulnerable here is the possibility of chronic stress causing a miscarriage, a spontaneous abortion. Now, the possibilities of this, the mere fact that stress can cause a miscarriage, that is run through all sorts of classic literature, all sorts of novels where key points of stress, of betrayal, of infidelities causes grief and stress and miscarriage. And I could cite the names of those books if I had ever actually read any of them. But this is a theme that goes through these, and it fits. It works. In lots of non-human species, what you will see is lots of stress causes spontaneous miscarriages. In some species, it takes the form of harassment. And often a pattern that you see is a high-ranking female in some social species, that's hierarchical. A high-ranking female can harass, can stress fertile, pregnant subordinates to the point where they miscarry. There's even some very elegant versions of this where the stress of the smell, the odor, the pheromonal signal of a big, scary, dominant female can cause miscarriage. So what's going on with humans with that? What's happening there? It can happen. It can happen, but the evidence for it is not very good. It's not good because it relies on what is dreaded in these fields of epidemiology, what's called retrospective data. Something bad happens to someone in terms of a disease, and it may be a disease where people think about stress, so they sit you down while the something bad is happening big time, and they say, oh, have you been stressed recently? And it's like guaranteed that someone is then going to say, yes, I've been stressed. When people are in the middle of some awful circumstance, they preferentially remember bad things in their past, and suddenly you come up with all sorts of bits of stressful history there. And you can even show this in studies. This was one classic study where, I don't know how they pulled this one off, and you couldn't do this with human subject rules anymore, but people were given some sort of drug that made them have like this horrible stomachache for weeks afterward. As you can see, this really is not a modern type experiment, but what happens at that point is the person goes to their doctor, and the doctor is in on the experiment and says to them, oh, this is terrible, you have an ulcer. They don't have an ulcer, they've just taken this medication, this experimental drug that's making them feel sick, and they don't know they took it. This crazy study, but the doctor at this point says, oh, you have an ulcer. So has anything stressful been going on in your life? And because everyone knows stress and ulcers, we saw a few lectures ago how it's more complicated than that. Stress and ulcers, people are suddenly coming up with all sorts of stressors that could explain why they've gotten sick. Same thing in all sorts of retrospective studies where you ask somebody at the time they've gotten bad medical news, so anything stressful going on recently, and people come up with numbers of those events like crazy. So it's very hard to trust studies like that. So what you do then is, in some cases, prospective studies, when you look at pregnant women and does stress increase their likelihood of miscarriage, that definitely can occur. One thing that you see, though, is it's a slowly emerging process. So the bias that one would have is, oh, the morning of my miscarriage, I had some horribly stressful event. That probably had nothing to do with it if it is stress-related. It's stressors stretching out quite a few days. So when that does happen, what are the mechanisms for it? And we go straight back to the earlier lectures. You're running for your life. You're shutting off all the optimistic long-term processes. You are delivering blood to wherever it's needed, those exercising thighs, and you're delivering blood at lower rates to parts of the body that are not essential. We saw earlier on one possible consequence of this is by delivering less blood to your gastrointestinal system. In some ways, you set yourself up for an ulcer more readily or less able to repair it. Down in this realm, women, female mammals who are chronically severely stressed when they're pregnant, they decrease blood flow to the fetus. And that's triggered by the sympathetic nervous system. And you do enough of that, and you increase the likelihood that you are going to lose the pregnancy. Okay, so that is the realm of what stress has to do with fertilization, ovulation, thickening your uterine walls, maintaining a pregnancy, high-tech in vitro fertilization. One additional area comes in having to do with another feature of sex, one that has long puzzled all sorts of scientists ranging from evolutionary biologists to psychoneuroimmunoendocrinologists, which is, oh, sex feels good. Lots of times, we take great pleasure from sex. We have a drive towards sexual behavior, pulling out Freud for the first time, a Freudian term. There's libido, sex drive. And another thing that occurs with chronic stress in both males and females, your libido goes down. You have less interest in sex. What is that one about? You are secreting all sorts of distress hormones, as we know, and two general realms where things happen. You've got all sorts of interesting parts of your body that are sensitive to certain types of tactile stimulation and more sensitive when you have high levels of certain stress.